We start observing the motion of this person at t is equal to 0. At this moment, he is not only moving with an initial velocity of 4 meters per second, but is also accelerating at constant acceleration of 2 meters per second square. So when we observe him after 1 second, his velocity will increase by 2 meters per second and will become 6 meters per second. So we can compare his velocity from the initial position where his velocity was 4 meters per second at t is equal to 0. We further observe his motion at t is equal to 2 seconds and we find that his velocity will further increase by 2 meters per second and will finally become 8 meters per second. We can again compare these results at t is equal to 0 and t is equal to 1 second, and we can find that at every second his velocity is increasing by 2 meters per second. Here we can see that the velocity of object is changing every second by the amount of its acceleration. So at the end of time t, its velocity will change by the amount at and final velocity will become u plus at, where u is the initial velocity and at is change in velocity. We can also cross check this formula by substituting the values of time and acceleration and find the values of velocity as at different points of time. So when we write the general formula for velocity of a uniformly accelerated object after time t, it is nothing but v is equal to u plus at, and hence we get our first equation of motion. Now we try to calculate the displacement of this object between t is equal to 0 and t is equal to t seconds. We denote it by small s, and this small s displacement is nothing but v average into time. And this v average can be written as u plus v by 2, that is initial plus final velocity by 2, just because this is a uniformly accelerated motion. We can further substitute the value of v, which is u plus at, and then after solving this equation we get s is equal to ut plus half at square. So we have just got our second equation of motion and we will list it down here. Now to get the third equation of motion, we will use these two equations which we have already got and try to eliminate t from these two equations. So from the equation v is equal to u plus at, we can write t is equal to v minus u upon a. We can substitute this value of in the first equation and this first equation will look like this. We can expand the terms, cancel the terms, make the denominator same, and after solving it we can get s is equal to v square minus u square by 2a. We can cross multiply 2a to get 2as is equal to v square minus u square, and just by rearranging the terms we will get v square is equal to u square plus 2as, and this becomes our third equation of motion.